Okay, for section 2.6, combinations of functions and composite functions, this is out of Unit 5 for Algebra 3 with trigonometry. I'm also going to break this up into 2 days. Not that the concepts are difficult, but they're confusing to students if I put them all together in one day. So the first thing we're going to do is what's called combinations of functions. It's basically operations. Operations in math are adding, subtracting, multiplying, and dividing. So that's what we're doing with these functions. So if you want to add two functions together, the notation is typically written in parentheses f plus g of x. So f plus g, it just means f of x plus g of x. It does not mean you add f and g and you multiply it by x. If you're taking the difference of two functions, instead of writing f of x minus g of x, mathematicians write it as parentheses f minus g, parentheses x. Same thing with multiplication and with division. So I'll go through a few examples first. So I have these two functions. F of x is going to be this function here, x squared minus x. And g of x is this function, 2x minus 6. Very basic functions, polynomials, they're the easiest ones to work with. So if I want to do f plus g of x, that means I want f of x, which is x squared minus x minus 6. And I want to add to that g of x, which is 2x minus 6. The parentheses I really didn't need because this is an addition. I'm just doing it to show you what this represents. So if I take away the parentheses, I combine like terms, I get x squared, a negative x and a positive 2x is giving me positive x. That's a bad x. And a negative 6 and negative 6 gives me negative 12. And that's all I'm doing with it right now. If I wanted f minus g of x, so f of x minus g of x, so I'm going to have x squared minus x minus 6, and I'm going to subtract from that 2x minus 6. Now in this case the parentheses are really important because this is saying I'm subtracting all of 2x minus 6. So let's drop the parentheses and distribute the negative. Now when I combine like terms I get x squared, negative x and a negative 2x gives me minus 3x. Negative 6 and a positive 6 gives me 0. So this is where this one stops. If I want to multiply the two, parentheses are necessary here. So I get x squared minus x minus 6 multiplied by 2x minus 6. And when I'm multiplying, I like to keep it very organized. So I try to write as neatly as possible because I do not always write very neatly. So first multiply x squared times 2x, I get 2x cubed. X squared times negative 6 gives me negative 6x squared. Negative x multiplied by 2x gives me negative 2x squared. And instead of writing it in a line here, I'm going to put it underneath this one because they have the same value with x squared. Negative x multiplied by negative 6 gives me positive 6x. Negative 6x multiplied by 2x gives me negative 12x. I'm putting it right underneath this because they're like terms. And negative 6 times negative 6 is going to be positive 36. Now when I add these together, I just come straight down. 2x cubed minus 8x squared minus 6x plus 36. And the last one looks like this. It's division. F of x divided by g of x. So I'm going to take the f of x, which is x squared minus x minus 6, and divide it by g of x, which is 2x minus 6. If the problem does not reduce at all, you can leave it like that. There's nothing wrong with that. But if you recognize that, yeah, I can reduce this, I'm going to factor the numerator, x minus 3x plus 2. And I can factor the denominator, 2 and then x minus 3. Now I've got a common term, x minus 3 over x minus 3 is 1. So this reduces to x plus 2 over 2. Do not cancel the 2's out. Okay, applications for combining functions, and we've started doing more and more word problems. The whole purpose of math is to do it for a reason. It's not that you're just going to sit there and somebody's going to ask you, oh, would you please add these two polynomials? It doesn't make sense to do that. But if you had a business and you wanted to find maybe the number of customers you have in a store per day, and you want to add Monday and Tuesday, you could have your functions represent number of customers on Monday, and you could have number of customers on Tuesday. And if we want to know the total of customers, you would add the total customers for Monday and total customers for Tuesday. Well, you could use a computer program and you type in these equations and it gives you that information. So anytime that you're dealing with business, that would be a good time to do that. Specifically, restaurants. The equations may model supplies. That you need for your restaurant. Or they could model, you have different restaurant chains. So maybe you own Jersey Mike's, you own the one here in Culpeper, and you own another one in Fredericksburg. And you want to know how many steak sandwiches you sold. You could have an equation that models it. I know those are kind of, if you were to own a business, you probably wouldn't make up these equations and do this. But when you're running a larger business, there are people out there who do the math for the owners. We could also do this with numbers. Let's go back to this first one here, this f plus g of x. What if I wanted f plus g of 2? Well, this is going to be f of 2 plus g of 2. So f of 2, I could put the 2 in here. And then add to g of 2. So 4 minus 2 is 2. 2 minus 6 is negative 4. Negative 4 plus 4 is 0. Minus 6 gives me negative 6. Or I could have just put it right in here. Let's say I have 2 squared plus 2 minus 12. 4 plus 2 is 6. 6 minus 12 is negative 6. So either way, I could do that with numbers as well. I can also do this graphically. I like doing these graphically. When I first started teaching this course, it was something students they never saw, and it would show up on SAT questions. And so I would tutor a lot of students with SAT questions, and I would help them with this. So let's look at this graph that I've created. So I'm going to call one of these f of x and one of these g of x. And let's go ahead and color it in so it's easier to see. So this blue one is going to be my f of x. This pink one is going to be my g of x. And even if I were doing this on paper, I tend to color them because then I don't get lost looking at the different functions. Now, let's look at different examples. Let's do f plus g of 2. That means I'm going to want f of 2 plus g of 2. And this is where the colors come in handy. F of 2, so here's 2. I'm going to go to the function, the blue function, come up here and find the y value. So this is going to be 4. G of 2, go to the 2, I'm going to go down to the pink function. I get negative 4. So this is going to equal 0. They don't have to be f plus g. I could do g plus f or g minus f. So let's do g minus f of negative 4. So that means I want g of negative 4 minus f of negative 4. G of negative 4, so I come to the x equals negative 4. G of negative 4 is equal to 2. F of negative 4, here's negative 4. I go to the blue function, it takes me up, that's equal to 4. 2 minus 4 is negative 2. Let's do a division. Let's do f of g of 0. So that means I want f of 0. Here's 0. The y value that goes with that is 5. G of 0. The y value that goes with that is negative 4. So this is going to be negative 5 fourths. And the last one I'll do is, let's do a multiplication. So let's do f times g of negative 6. So f of negative 6 times g of negative 6. F of negative 6, there's negative 6. I have a 2. G of negative 6, there's negative 6, I get negative 1. So my answer is negative 2. That's the end of this part. The second part we'll do the composite functions or composition of functions.